All right, we're looking at numbers 4 through 9 here, and I've already put in the function into the graph, so we're going to take a look at this graph. Oops, leave it in the screen here. It's working. All right, so first of all, we're going to determine the maximum possible number of roots. So this aside for a second, number 1, what is the maximum possible number? That is always going to be the degree of the function, or the highest possible exponent. In this case, it's 3x to the 5th, so the maximum possible number of roots is 5, because the highest power is to the 5th. All right, number 5, determine the actual number of roots. Now we look at our function here, and we can see that it crosses the x-axis just once. So our actual number of roots is only going to be 1. Determine the maximum possible number of extrema. So we take the highest number, highest power, leading degree, and you subtract 1. So we say 5 minus 1, that gives you the maximum possible number of extrema, which is going to be 4. It's always going to be 1 less than the degree of the function. So if this had been to the 7th power, our maximum possible number of extrema would have been 7 minus 1 is 6, just as a side example. Okay, number 7, determine the actual number of extrema. So if you look here, and you can see it if you graph it yourself, you can see how it kind of comes up and then goes down again and then up. So we have an extrema. It looks kind of like this if you're zoomed in on it. Kind of does something like this. So we have an extrema here and an extrema here. Even though it's mild, it's not real easy to see. If you zoom in, you can see it better. So our actual number of extrema is going to be 2. Extrema are just every time it changes direction. So it makes a bump here, makes a bump here, and continues up. Each bump is an extrema. Okay, determine the direction the graph begins and ends. So we can see that the graph starts downward and goes upward. So that's going to be down, up for our directions. Determine the possible rational roots. So the rational root theorem, just as a quick review, we take our p-values and our q-values. So our p is this number here. Our q is this number here, the coefficients. So p-values can be any factors of 4. So that's going to be plus or minus 1, plus or minus 2, plus or minus 4. Our q-values are, this is 3, right? Q is 3. So the factors of 3 are plus or minus 1 and plus or minus 3. So now the rational root theorem says that you do p over q to find possible rational roots. So that would mean that we take all these p values and put them over all the potential q values. So that's going to be plus or minus 1, plus or minus 2, plus or minus 4. And we're going to do these over plus or minus 1, plus or minus 1, plus or minus 1 to show this one being covered. Now we're going to do the same p's but over the other q value. So these are each possible answers. So we'll have plus or minus 1, plus or minus 2, plus or minus 4, and then over the other factor, which is plus or minus 3, plus or minus 3, plus or minus 3. So all of these values are potential rational roots of this polynomial here. So these would all be the answers here. Just be this list. All right.